CC's Math Tape 133, Radical Equations Reducible to Quadratics. Our objective on this tape is to solve radical equations that can be reduced to quadratic form. Let's begin by going through the procedure that we follow for solving a radical equation. The procedure is, first, to isolate one radical on one side of the equation. Isolate one radical on one side of the equation. Second, we raise both sides of the equation to the power that matches the index of the radical. Raise both sides to the power that matches the index of the radical. Remember that the index of the radical is the number that tells us which kind of root. A 3 index means cube root. A 2 index is understood and not written and means square root. The next step is to solve the resulting equation. On this tape, the resulting equation will be quadratic. Once we solve the resulting equation, the final step is crucial. We must check all possible solutions in the original equation. Check all possible solutions in the original equation. This is the step that many of us forget, and it absolutely must be done. Be sure that you check in the original equation. Let's begin with an example. Example 1 is 4 times the cube root of x squared subtract 3 equals 13. 4 times the cube root of x squared subtract 3 equals 13. We first isolate the radical. The extra term on the side with the radical is the 3, so we'll add 3 to both sides, and that gives us 4 times the cube root of x squared equals 16. The radical term is isolated, and we can square at this stage. However, since we have a common factor of 4, if we simply divide both sides by 4, this simplifies the equation. We get the cube root of x squared is equal to 4. Now we're ready to raise both sides of the equation to the power that matches the index of the radical. Notice that this is a cube root, and so we must cube both sides. This means that literally we raise each side of the equation to the third power. On the left-hand side, when we cube the cube root, the cube and the cube root cancel. On the right-hand side, we cube 4. Cube of cube root of x squared is x squared. The cube of 4 is 64. 4 times 4 times 4. Now we have a quadratic equation which can nicely be solved by the principal square root method. If we take the square root of both sides of this equation, then we'll get our two answers. X is equal to plus or minus 8. Now we're down to the final stage, which is to check each possible answer in the original equation. The original equation was 4 times the cube root of x squared subtract 3 equals 13. So we'll check our possible solutions in that equation. So here's the equation rewritten. We're going to try 8. We'll check 8. And so we have 4 times the cube root of, the number we fill in here is 8. 4 times the cube root of 8 squared, subtract 3 on the left, 13 on the right. On the right we don't have any work to do, so let's just finish up the left-hand side. The cube root of 8 squared, we work inside first, square 8, and that gives 64. And so we have 4 times the cube root of 64 subtract 3. Cube root of 64 is 4, and so that gives 4 times 4 subtract 3, which is 16 subtract 3, which is 13. That means that on the left we got 13, on the right we got 13, and so this one checks. Now we check x equals -8. By the same procedure, we check it in the original problem. Here's the original equation, and we fill in -8 in place of x. So we have 4 times the cube root of -8 squared, subtract 3 on the left, and 13 on the right. When we square -8, we get 64. So we have 4 times the cube root of 64, subtract 3. That gives, cube root of 64 is 4. 4 times 4, subtract 3, which is 16, subtract 3, which is 13. This means that the -8 also checks, and so our solution is the double solution, x equals 8 and x equals -8, two answers that both work. Let's look at a second example. Example 2 has a square root. The square root of x plus 8 subtract 1 equals 2x. We must first isolate the radical on one side of the equation. The radical is the square root of x plus 8. That means we must get rid of this 1 being subtracted. If we add 1 to both sides, that gives the square root of x plus 8 equals 2x add 1. Since it's square root, we raise both sides to the second power, square both sides, and that gives the square root of x plus 8 squared on the left and 2x plus 1 squared on the right. Squaring the square root cancels, leaving us x plus 8 on the left. On the right, we are tempted to use an illegal shortcut, but if we write what this actually means, we avoid the danger. On the right-hand side, we're squaring this binomial. That means we're really using 2x plus 1 times 2x plus 1. When we square the 2x plus 1, that is multiply 2x plus 1 times itself, using the FOIL method, we get 4x squared plus 4x plus 1. Now you notice that we have a quadratic equation, but it's not in standard form. To get the quadratic equation in standard form, we must have an x squared term, an x term, a constant term equals 0. The simplest thing would be to subtract x and subtract 8 from both sides. And when we do, we get 0 equals 4x squared plus 3x subtract 7. Now we have a quadratic equation which can be solved either by factoring or by the quadratic formula. This one factors nicely into 4x plus 7 times x minus 1. When we set each factor equal to 0, we get either 4x plus 7 equals 0 or x minus 1 equals 0. Solving those, we get x equals -7/4 or x equals 1. Here our two possible solutions are, and we must check them both to see what works. Let's begin by checking the x equals -7/4. And we're going to check that in the original equation, which was before the radical was isolated. The square root of x plus 8 subtract 1 equals 2x. On the left-hand side, the x will be replaced by -7/4. On the right-hand side, the x will likewise be replaced with -7/4. On the left-hand side, we'll add in the radical and get -7/4 plus -32/4. Subtract 1. On the right-hand side, the 2 and the 4 cancel, leaving us with -7/2. Inside the radical, -7 plus 32 is 25, and so we have the square root of 25/4. Subtract 1. The square root of 25/4 is 5/2. That gives us 5/2 subtract 1, which is 5/2 subtract 2/2, which is 3/2. So on the left-hand side we have 3/2. On the right-hand side we have negative 7/2. This does not work. That means that the number we were checking, which was negative 7/4, did not work. So that one will be omitted from our list of possible answers.